I'm in Moscow, at Moscow School 1514 with Sergey Lisakov, who's very kindly showed me around, and we're seeing around his school in a bunch of experiments. This is one that's been made by his now principal. Yeah. His principal, Yuri Bobrinov, and his students. So thanks again for being so welcoming, showing me around.
You're welcome.
And can you explain what this is?
Yeah, sure. This is a very interesting device which allows us to measure the magnetic field of the Earth. First, we make the parallel, the arrow. So first we make parallel the arrow of the compass and the line in the middle of these two coils. Now we will. So now we know the direction of the magnetic field of the Earth. So now we will add the current into these coils. So these coils will become an electromagnet. So we will compare the magnetic field of the Earth, a magnetic field created by these coils. To achieve that, we need the arrow to be placed exactly by 45 degrees, because this way we know that, okay, the magnetic field of the Earth and the magnetic field from these coils are the same. So we turn the current on, and we can see that the arrow will move a bit, and by controlling the current, we can achieve the 45 degrees and like this. After that, we need only integrate the flux, and we will measure this way the strength of the magnetic field of the Earth, because we know it is equal to the magnetic field by this electromagnet.
Excellent, that's a beautiful experiment.
Thanks to you.
Yes, thank you, Yuri.
Electromagnet. When the current is off, it is not a magnet. If you turn on the current, it will be a magnet. Then I like to ask students, how can we stop the magnetic properties of this magnet? They tell me, of course we can turn off the current. Okay, we turn it off. But the nail is still there. Then I ask them, how we can make it fall finally? They tell me, we can change the polarity. Okay, we change the direction of the current. Then we turn the current on. We expect it to fall down, but it is not falling down. What's the reason? The reason that we initially made the high value of the current. That's why it is not falling down. We are going to repeat this experiment. We change the direction of the current again, but now we will start with a small amount, with a small value of current. Okay? And now it is falling down. And the second experiment, which is called homopolar motor, we need for that magnets. We need a battery cell with the plus pointed to down, and then a copper wire. When we place the copper wire like this, we have a circuit, and it rotates because the current produces magnetic field which interact with the magnetic field of this constant magnet.
Beautiful, thank you. Oh, and can we quickly see lens as well?
Sure. This is a classical experiment. Yeah. We have two aluminum foil tubes, and one contains not a lot of coils, so the magnet falls quite quick, as we expect normally. Here the tube is thicker, so if we put the magnet inside, it falls with a significant delay. And by the way, when it falls, I can feel that the tube becomes heavier. And the reason of that the changing of the magnetic flux, which is produced by the moving of the magnet, induce the current in this foil, and the current in this foil produce magnetic field, which interacts with the magnetic field of the magnet. But it doesn't matter which side, which pole down, I will make this magnet fall, because anyway the direction of the current, it could be different, but in any way it should prevent the changing of the magnetic flux.
Excellent, thank you. I hope you enjoyed seeing some of these experiments in Russia. I know I've absolutely loved it. Check out my other videos, both from Russia and from all around the world, as I ask scientists and educators to share their favorite experiments with me. Subscribe if you want to follow me biking across Europe this summer, going to many more countries, asking many more people my favorite question: what's your favorite experiment?